let's say if we have this quadratic equation and we want to find the sum and product of the roots. So, first thing you might be thinking is, well, can we factor this at all? So first step, let's try to find the GCF. So the greatest common factor for all of these terms. What do all of these terms have in common? And that's going to be a 2, right? All of these things have a 2 in common. If you take out a 2 from 2x squared, you're just going to be left with x squared. If you take a 2 out of 10x, you're just going to be left with 5x. And if you take out a 2 from 12, you're just going to be left with 6. And you can actually factor the thing on the inside. Two numbers that multiply up to be 6 and add up to be 5 are 3 and 2. So this means that x is either equal to -3 or x is equal to -2 based on the zero product property, right? So the roots of this equation are x is equal to -3, x is equal to -2. So that means that the sum of these two roots is just going to be -3 plus -2, which is -5. So the sum and the product of the roots is just going to be these two things multiplied out together. So -3 times -2 is just going to be +6. Now, what if I told you that there was a much quicker way to do this problem? So if you wanted to find the sum of the roots for a quadratic equation in this form, in standard form, well, the sum of the roots is just going to be -b over a. This is the sum. And then the product of the roots is just going to be c over a. So these variables are represented by the coefficients of, well, in this case, a represents the coefficient of the x squared term, b represents the coefficient of the x term, and the c represents the constant. So in this case, we said that the sum was -5 and the product is equal to 6. So using these new formulas, let's see if this actually works. So we know that the sum is equal to -b over a. We know our b term is 10, right? This is our coefficient of the x term. And then the a term is just this 2, right? So -b over a is -10 over 2, which is equal to -5. And you notice how this represents the sum of the roots, right? This matches up. If we want to find out the product of the roots, it's c over a. In this case, our c term, our constant term, is just going to be 12, and our a term is 2. So 12 over 2 is equal to 6. And boom, you'll notice how this represents the product. Let's say if we have x squared plus 4x equals to 7, and we want to find out the sum and product of these two roots. So we want to find out the sum and product of the roots of this quadratic equation. Now, the first thing you got to do is you got to write this in standard form. So we know that standard form is ax squared. This is the thing I just said earlier. It's just ax squared plus bx plus c is equal to 0. So basically, you want to move everything to one side. So that's kind of this first step, right? You notice how one side is equal to 0, and then the other side, it has all this stuff in it. So in this equation, let's subtract 7 from both sides. So we have x squared plus 4x minus 7 is equal to 0. And now we can use the sum and product of the roots formulas. We know that the sum of a root is equal to -b over a, and the product of roots is equal to c over a. So the sum of a root, we know that b is equal to 4. We know that a is equal to 1, right? If there's nothing in front of the x squared, there's just this invisible 1 in front of it. And we know that the c value is equal to -7, right? C is equal to -7. So -b over a is just going to be -4 over 1, which is -4. And we know that the product of roots is c over a. So we know that c is equal to -7 and a is equal to 1. So the product of the roots is just going to be negative. For example, let's say if we have x squared equals, let's say, 4. Find the sum and product of the roots. Once again, the first thing to do is write this in standard form. So ax squared plus bx plus c is equal to 0. Just move everything to one side. So we have x squared minus 4 is equal to 0. And now using the sum and product formulas, find the sum and product of the roots. Well, in this case, you'll notice how there's actually no bx term, right? Normally, in the standard form thing, we have ax squared plus bx plus c is equal to 0. However, this thing right over here is actually in standard form because, like, even though it doesn't have a bx term, you can think about this equation as x squared plus 0x minus 4 is equal to 0. So now you'll notice how our equation is actually in standard form. It's just that there's no b. So the sum of the roots is negative b over a. We know that our b term is equal to 0. And it really doesn't matter that our a term is equal to 1 because 0 divided by anything except for 0 is going to be 0. So yeah. So negative b, so negative 0 divided by a, we know that's 1. That's just going to be 0. So the sum of the roots is just going to be equal to 0. And the product of the roots is c over a. We know that c is equal to negative 4 and a is equal to 1. So negative 4 divided by 1 is just going to be negative 4. And boom, we have our answer. Now let's do something a little bit different. So this time, we're given that the sum of our roots is 12. And we want to find out what the product of our roots is. So given our quadratic equation, what's the product of the roots? Well, let's kind of plug in what we know. So we know that the sum of the roots is equal to 12, and we know that the sum of the roots, the equation for it is negative b over a. Now we know our b value is equal to 10, but we don't know what our a value is. So we can just say that 12 is equal to negative b, so negative 10 over a. We don't know what a is. And now you'll notice how we have this mini equation. So we can solve for a. So 12a, if we multiply both sides by a, we get 12a is equal to negative 10. And we get that a is equal to negative 10 over 12. Or we can simplify this out to negative 5 over 6. So a is equal to negative 5 over 6. And now that we have the a value, we can find the product of our roots. We know that our c value is equal to 12. And we know that the a value is now negative 5 over 6. So the product of the roots is just going to be c over a, or 12 over negative 5 over 6. And it might be clearer if I write it out like this. So 12 over negative 5 over 6. Do the keep change flip. 6 over negative 5. We get 72 over negative 5 as the product of. Now going back to the first example, there's actually another way to find out the sum and the product of the roots. So in this case, right, our first step we did was we took out a 2 from every term. Now, what you notice is that we can rewrite this whole equation as x squared minus negative 5x plus 6 is equal to 0. Notice how I didn't actually change the value of this equation, right? Negative still makes a positive, right? So everything here is still equal. And the formula for the sum and the product of the roots in the quadratic equation, this is the other formula for it. So we have a times x squared minus the sum of the roots times x plus the product of the roots. And you notice how the sum of the roots, well, we said that was equal to negative 5, and this matches up with this negative 5 next to the x. And we also notice how the product of the roots plus the product of the roots, well, we notice how we have this 6 at the end, right, plus 6, and that matches up with the product of the roots here. If you want to find out the sum of the roots and the product of roots of this equation, well, what you can do is you first factor out the coefficient of your x squared term. So you take out a 3 from all of these terms. So you have 3 times x squared plus 3x plus 4 equals to 0. And now you can just use the formula, right? We know that the product of the roots, well, you notice how this part matches up with this last part. So the product of the roots is just going to be equal to 4, right? And then the sum of the roots, this is just going to be equal to negative 3, because we can rewrite this thing as 3 times x squared minus negative 3x plus 4 is equal to 0. And then you notice how now it's in the correct form, right? So the sum of the roots, if you're using this way to solve this problem, the sum of the roots, just know that it's always gonna be like the opposite of what's going on here. So it looks like the sum of the roots is 3, but in fact it's actually negative 3. It's always the opposite of what you're expecting. Okay, so given that we have this equation, and we're given that the sum of the roots is equal to negative 4, and the product of our roots is equal to negative 5, find out what b and c are equal to in this equation. Well, we have this formula down here, and right now we can rewrite this equation as 2 times x squared minus negative b over 2 times x plus c over 3 is equal to 0. All we did was we took a negative out from b over 2, so we're left with negative b over 2. And negative still makes positive, so everything in this equation is still equal, right? We just only changed how this equation looks. You'll notice how the sum of the roots, right, in this equation, right over here, that kind of matches up with this part of our equation, right? This negative b over 2 matches up with the sum of the roots. And we know that the sum of the roots is equal to negative 4. So we can set these two things equal to each other, right? Because we know the sum of the roots is equal to this part of our equation. And we also know the sum of the roots is equal to negative 4. So we can set this thing equal to each other. So we have negative b is equal to negative 8, which means that b is equal to 8. We also know that the product of the roots, well, that kind of matches up with this part of our equation, which is c over 3. Right? C over 3 represents the product of our roots. And we also know that the product of our roots is negative 5. So c is just going to be equal to negative 15. And there we go. If we wanted to find out the equation of this quadratic equation, all we have to do is we have to plug in, we'll just plug in kind of everything we know. So we have 2 times x squared minus the sum of the roots. We know the sum of the roots is negative 4. So minus the sum of the roots, x, plus the product of the roots, we know that's negative 5. So plus negative 5, or just minus 5, is equal to 0. We have 2 times x squared, negative makes positive, 4x minus 5 is equal to 0. And then finally, 2x squared plus 8x minus 10 is equal to 0. And there we have it. Find the equation of this quadratic equation using integral coefficients. So integral coefficients just mean that the quadratic equation, if we have something like this, a, b, and c are all integers. So that's what a quadratic equation with integral coefficients have. All of these coefficients and the constant are integers. So an example of this would be something like 3x squared plus 5x plus 6 is equal to 0. You'll notice how 3, 5, and 6 are all integers. An example of an equation that does not, a quadratic equation that does not use integral coefficients is, let's say, if we have 3/2 x squared plus 1/2 x equals 0. Right? 3/2 and 1/2 are not integers. So luckily for us, our equation is already in this form. Right? We can think about this as 1 times x squared minus bx plus c is equal to 0. So if there's nothing in front of the x squared, you can just think about it as 1 times everything inside what I have here. So now it's going to be x squared minus the sum of the roots. So in this case, the sum of the roots is negative 4 and 1/2. So this is just going to be x squared minus the sum of the roots, which is negative 4 and 1/2 times x. So, and then this is going to be plus the product of the roots, which is just negative 3 and 1/4 plus negative 3 and 1/4 is equal to 0. And we can rewrite this as x squared plus 4 and 1/2, right? Because negative makes positive, x minus 3 and 1/4 is equal to 0. Now the problem is this quadratic equation does not use integral coefficients, right? You notice how 4 and 1/2 is not an integer, right? 3 and 1/4 is not an integer. So all I'm going to do is I'm going to multiply this equation by the lowest common multiple of 2 and 4, which is just 4. And now I have 4x squared plus 4 times 4.5. 4 times 4.5 is 18. So 4x plus 18x minus 3 and 1/4 times 4 is just going to be 13. So minus 13 is equal to 0. And you'll notice how now everything is an integer, right? 4 is an integer, 18 is an integer, and negative 13 is an integer. And that is the answer. This last part of the video is just optional to watch, but I'm just going to show you the proofs for the formula. If y'all don't want to see that, then sure, just click out of the video. But yeah, it's just important to know where these formulas come from. So let's prove the sum of roots. So I'm gonna sum of the roots formula. And I'm just going to prove why the sum of the roots in a quadratic equation is going to be negative b over a, why this is true. So we know that if we want to find out the roots of any quadratic equation, so ax squared plus bx plus c, right, you can use the quadratic formula. And the two roots that you get from using the quadratic formula is x equals negative b plus the square root of b squared minus 4ac all over 2a. And then the other root that you get is x equals negative b minus the square root of b squared minus 4ac. And then all over 2a. Right? This is the quadratic formula. The two roots you get is x equals negative b plus or minus, right? The square root of, and then blah, blah, blah. Now, if we wanted to find the sum of the roots, well, you would just add these two things together, right? If this is one of the root and this is the other root, well, you would just add these two things together. You would get negative b plus the square root of b squared minus 4ac all over 2a. And then you would have plus negative b minus the square root of b squared minus 4ac all over 2a. Now, because these two fractions, they have the same denominator, we can actually combine this thing into one fraction. So negative b plus the square root of b squared minus 4ac, and then minus b minus square root of b squared minus 4ac all over 2a. So yeah, all we did was we combined these two fractions together because they have the same denominator. You'll notice how we have a negative b squared minus 4ac and we have a positive b squared minus 4ac. So both of these cancel each other out, and we're just going to be left with negative b plus negative b, which is just negative 2b. And now we can simplify this. We have negative 2b over 2a. This 2 cancels out with this 2, so we're just left with negative b over a as the sum of our roots. Now I'm going to prove to you that the product of the roots is c over a. So once again, the two roots I have is these two things, but this time I'm going to be multiplying them together. So when we multiply the denominator together, that's the simple part. 2a times 2a is 4a squared. The numerator, on the other hand, is a little bit more tricky. One thing you might notice is that these two things are a difference of two squares, so you can do that. But just to kind of show you everything, I'm just going to FOIL everything. So negative b times negative b is b squared. square root negative b times negative b squared minus 4ac is just going to be plus, right? Because negative negative makes a positive. So this is just going to be plus b times b squared minus 4ac. Positive b squared minus 4ac minus b is just going to be negative b square root of b squared minus 4ac. And then these two things multiplied out together, right? B squared, square root of b squared minus 4ac times negative b squared minus 4ac is just going to be negative of b squared minus 4ac, right? Because this square root and this square root is kind of just going to cancel out. So you're just going to be left with this. And you notice how we have a positive b squared minus 4ac and a negative b squared minus 4ac. So these two things cancel out. So now we're left with this. And let's distribute the negative sign. So when we distribute the negative sign, we are going to get this negative makes this negative b squared and then plus 4ac. So negative b squared plus 4ac. Now you'll notice how this positive b squared and this negative b squared cancels out. So we're left with 4ac divided by 4a squared. This 4 cancels out with this 4, and this a cancels out with this one of the a's in a squared. So we're just going to be left with c over a, right? So if we have 4ac, we have 4a squared is the same thing as a times a. So this 4 cancels out, this a cancels out, you're just left with c over a, which is our formula. Last proof I want to do is this formula. I want to show you why a in parentheses x squared minus the sum of the roots x plus the product of the roots is equal to 0. So to do this problem, once again, just have to remember, I'm going to be using these two formulas actually. So we know that the sum of the roots is equal to negative b over a, and then the product of the roots is equal to c over a. Now start off with a standard equation. So a quadratic equation in standard form. So we have ax squared plus bx plus c. All I'm going to do is I'm going to factor out an a from every term. So I factor out an a, I'm going to get x squared plus b over ax plus c over a is equal to 0. Now let me rewrite this equation as a times x squared minus negative b over a times x, right? I'm allowed to do this because negative negative makes a positive, plus c over a is equal to 0. Now you notice how we know negative b over a is equal to the sum of the roots. So the sum of the roots, we can substitute it in here, and then the product of the roots, which is c over a, we can substitute it here, ending up where we end up with this formula now, right? The sum of the roots goes right in here, and the product of the roots goes right in here.